Then what you also need to know is the basic process of setting up a field network. Although processes can vary amongst different field network technologies, the theme is the same, and this is why interviewers ask this. For example, the process usually goes like you need to get power to the field network. The trick here is that in some technologies, the devices can get power from the signal cables. For instance, if you are implementing or setting up an ASI network, you can't use any regular power supply. You need to use the power supply that comes from the manufacturer of that ASI network. Then the second point when setting up a field network is that the devices need to have addresses on the network. These could be node numbers or IP addresses if the field network is Ethernet based. Then lastly, it is verifying that the devices on the field network are healthy. For example, you can use certain status LEDs to see if all the modules on that field networks are healthy, or you can look at the diagnostics on the master or from the PLC to see if all the modules on that particular field network are healthy. So the theme is get power, do addressing, and do the verification when setting up a field network. Then the next point is problem solving. When it comes to this, you should know how to diagnose a field network. Of course, you can't know how to diagnose every type of field network. It is just that there is a theme here as well. Typically, a field network will be Ethernet TCP based or serial 3-wire, 2-wire, or anything that is not Ethernet. Here is an example. With Ethernet, the basic approach if a module is not communicating is that you first need to check if the module has power. Then secondly, you can check the status LEDs where the Ethernet cable is connected to or plugged to see if they are flashing correctly and indicating that there is traffic on the network. Then number 3, you can look at the topology to see if other devices are also down in that network. If there is no redundancy, then multiple devices will be lost if one link is broken. You can also verify if the cable is not damaged, and you can also ping the devices to see if they are indeed on the network. If a module on a field network is not communicating on a serial-based network, the approach can be check power, look at the status LED to see if the slaves can see the master, check on the master's LEDs or LCD to see if there are slaves that the master does not see. Also, you can verify the network cable as well. These are just a few points, and you can add on these based on your experience. You must also have an idea of the diagnostic tools. For certain networks, for instance with Ethernet based networks, you can use a laptop to ping devices on the network. You can also get Ethernet cable testers. These are very useful and I have used them a lot. With serial based network, you can get diagnostic tools like a Profibus network tester. The master can also be used to get diagnostic information of the slaves. You can use addressing tools to verify if the slaves have the correct addresses. You can also use various network sniffers to check the network traffic, cable resistance, or if there are any data leaks on the network. Also mention your problem solving experience. Describe the problem, the step-by-step method that you used to find out what was wrong and how you fixed the problem, and your interviewers will be really impressed. When it comes to problem solving, give as many examples as you can. Engineering people love to hear stories about breakdowns and how you managed to fix them. Lastly, although not as important as the other points, but good to know, is how to interface field networks with the PLC. You need to know the software required. Some field network technologies come with a software package when you get them, so that you can configure the network and download the configuration to the master. Secondly, you can use the PLC programming software to set up the field network. In this case, you need to download the drivers, electronic data sheets, profiles, or plugins that you load to your PLC programming software and allows the PLC to be able to communicate and get data from the field network. You also need to know the hardware required. In some cases, you may need a special PLC card or module in order for the network to communicate with the PLC. If the field network is Ethernet based and uses the same protocol with the PLC, then you can just get an additional Ethernet card from the manufacturer to communicate with the field network if you do not already have a spare port on your PLC. Knowing data acquisition methods between the PLC and the field network is useful. So this could be IO scanning, message read, or produced consumed. This varies on the type of field network that you have as well as the type of PLC. As I said, this may not be important for job interviews, but it is good to know, and it is something you can look into if you want to improve your control and automation skills.